Now I introduce dynamic programming. The idea of dynamic programming is to avoid solving a complicated problem directly. Instead, it splits the complicated problem into many small pieces or a sequence of simple problems. By solving a sequence of simple problems, dynamic programming gets the solution for the original complicated problem. Right now, we use dynamic programming to find the optimal policy by solving Bellman optimality equation here. Here, because this is the optimal action state value function. The problem is a difficulty because when agent moves from his current state to next state, it selects action A and the policy pi. Also, he needs to think about his environment, because the next state not only depends on the action selected by the agent, also depend on the environment to get the best reward. Right now, dynamic programming uses 3 steps to solve this Bellman optimality equation. First is a policy evaluation. Second is a policy improvement and iteration. Let's first select initial policy pi. And the Bellman equation used to update the state value function at all state. Because this is under policy pi, so to update the state value function at the state S, this is the expected return. Expected return means that we need the contribution from all the possible next state as a prime. That means this sum is over this pi distribution, or over this all the actions A. To calculate this state value function, we rewrite this equation in iterative equation format, so we can get this updated equation. For example, to calculate the state value function at the state S, we need the next state S prime. Here is for nearest neighbors. Then we state all the we update state value function at all the state. When k tends to infinity, state value function vk converges to the state value function and the policy pi. Once we get this, we have this state value function, then we can use it to improve the policy. To improve policy, first we need to check the policy, the current policy is the optimal policy or not. That means we scan, for example, we select each action under the policy pi, calculate the Q value, Q function here. This Q function here, and to calculate we need the next state, this state transition probability and the reward are from the environment. And see which A can generate the maximum Q. If this maximum Q value is greater than the state value function and the policy pi, that means this current pi is not the optimal. So we need to search for a better one. So to search the better one, we define improve the policy. Improve the policy because our purpose is to find this optimal policy and get the optimal return. So we define this improve the policy as deterministic policy. That means we only update this action. That means whenever we reach this state, we just select this action. So then we see next how can we use this state value function. We got last step or in the policy evaluation to improve, get the new policy. We see say a policy is better, policy prime better than policy pi. That means at all the state, this state value function is larger than the state value function and the policy pi. Because you are not right now the policy pi prime, the only difference is this action A. So other than this action A, the rest of them are the same as both policy have the same options here. So the new policy pi prime we calculate in this formulation. That means we under the new policy pi prime, see how can we select select this A value, make this value Q. Actually, this Q value is a maximum, and then we get this new policy. From this new policy, of course, we calculate the state value function under the new policy prime. If this converges to the optimal policy and the optimal state value function, we stop the iteration. Otherwise, we use this new or improved policy in the policy evaluation step to generate a new state value function distribution. And then we use that state value distribution to calculate, improve this policy again, until we get the optimal policy and optimal state value function. For more details, please check with this reference. Thank you. Bye.